Let's understand calculus through a simple problem. Calculus, while appearing complex with its symbols, is essentially a language. Just like learning a new spoken language, understanding the symbols and rules allows you to piece together its meaning. The concepts, when broken down, are not as difficult as they might initially seem. Calculus is fascinating and super powerful mathematics, and is used pretty much everywhere in modern engineering technology. Here's the entire calculation process. By following along, you'll grasp this mathematical tool hidden behind what seems like complex language. An engineer is designing a walking path that follows the shape of a gently rising hill. The path is modeled by the function y equals x, which means that as you move to the right along the x-axis, the height increases at the same rate. The path starts at x equals 1 and ends at x equals 3. The area of interest is the region beneath this line, above the x-axis, and between the vertical lines x equals 1 and x equals 3. This area represents the land that will be paved for the walking path. Using calculus, calculate the exact area in square units that needs to be paved. First step is to understand the setup. We're trying to find the area underneath the line y equals x from x equals 1 to x equals 3. This is a perfect example where we can use integration, which is the calculus method for finding the area under a curve. You can picture this region as a slanted triangle that starts at x equals 1, goes up along the line y equals x, and stops at x equals 3. The area between this line and the x-axis is what we're interested in. Next, set up the integral. To find the area, we use a definite integral. That means we will add up an infinite number of tiny vertical strips underneath the curve y equals x, starting from x equals 1 and ending at x equals 3. Then, use the integration rule. To integrate the function y equals x, we apply the rule that says, when you integrate x, you get x squared divided by 2. This result is called the antiderivative of x. Next step is to plug in the limits. Now we take the result, which is x squared over 2, and evaluate it at the two boundary points. First, plug in the upper limit, which is x equals 3. 3 squared is 9, and 9 divided by 2 is 4.5. Next, plug in the lower limit, which is x equals 1. 1 squared is 1, and 1 divided by 2 is 0.5. Finally, subtract the two results. 4.5 minus 0.5 equals 4. Finally, the exact area under the curve from x equals 1 to x equals 3 is 4 square units. This method works whether the curve is straight, curved, or even wiggly. It's the power of calculus. It turns a messy-looking area into something exact and logical. This was a gentle example, using the line y equals x. It helps build your understanding before moving to more complex curves. That's it for this question. Hope you enjoyed it. Please subscribe to our channel. If you're looking for tutoring on final exam level questions, check out my YouTube channel at MathTutor8285. You'll find helpful explanations and strategies to ace your exams.